Okay. First things first. Let's compile a version of 4Coder that has that new symbol in it. I guess I'll just stick with external. That's descriptive enough. Okay. How do we do this? Here. Okay, let's see if that worked. There we go. So now that highlights properly. Now we just have to make it work. Okay. This is a pre-proc, so we'll go here. And this will be a flag on the node, which those live here. This is a external node. Node resolves declrefs, but generates no code. Oh, my formatting is all over the place. It doesn't actually matter, but while I'm here. Okay. Okay. There's that. So we go to the parser. Where do we do pre-proc? So we'll say new one here that says if we see external, then we want to just do a normal parse, but only one thing. So I think what we need this to be able to be called for just one thing and to give us that thing back. Or no, I guess not. I guess we don't need it back. It just adds it to the tree. It just adds to the tree. Right? I think it can just add it to the tree. So let's say... Let's just try it. Let's just see what happens. Let's go nuts. We're gonna say... does it need... No, it doesn't need anything. So this is a external node. External. Needs none of that stuff. Let's just say do parse on the external node. Let's just do that. Let's assert that the external node, that we got it, and just do that. And then here, if so, after one loop of this, if root type, if we're in an external thing, we just stop here. We go back. So root equals root parent. Or no, we don't even have to do that. We're calling this, so we just stop. We parse one thing and then we stop. That might be all we have to do. So let's do this one thing at a time. Does this still work just normally? Yes. If I add one of these, what is that actually? These are pound defines. They're just integers though, so it's an S64 called standard out file number. And we'll say it's const, why not? It's never changing, so equals 0. Actually, we don't want to give it a value. We just want it to tell, because we're not generating anything about this. We're just telling it what it is. It's an S64. That's fine. Okay, we don't quite make it there. We crash. Oh, because we need to pass. Okay. We do in fact need to skip the token. It's important. Okay, that so far so good. So print AST. If we come across an external, how do we print that? Oh, we also need to what do we call it? Flags? Node flags? What do we call it? Node flags. Node flags. We're gonna add to it this new one. So we're gonna flag this node and say, hey, this is external. So then later on, when we go to do code gen, it will, it knows it can skip over those. So back to here, we are there's kind of nothing to print here, so we're just gonna say nothing to show. And then in global scope, we don't care about that at all. So in global scope, this will be a case where if we see one, we just don't care. Okay. More housekeeping. Print node nicely. What does it say? Decal struct function. Why is that only now showing itself as a problem? I don't know, but oh, because I'm not breaking. Oops. Although, wait a minute. I made a big mistake here. What did I do? Let's get rid of this. Do we compile? Yes. So what did I do here? Copy this whole thing. External. I did something goofy. Okay. Great. And great. Okay, so we should see that in the tree now. Let's verify that. Where would that be? That would just be in the file it shows up in. So let's grep for Linux include. So there it is. It didn't append the children, so that's a problem. So I called do parse on the root. So why didn't that work? We create the node, we get one. It should, at that point, have a child. Let's see what happens. Parser. Let's go here. External node should look like line 20, which it is. Okay, go into here. Oh, what did we just do? What just happened? Parser. Go into it. Lexer is the current lexer. If token cursor 16 is less than... Oh, weird. I've hit a weird... This should be less than or equal to. No, wait a minute. Yeah, no, that's definitely not true. What is happening here? The token... What are we doing? Let's go in here. and we're going to say the Lexer has 16 tokens left in it, which look like wait, the cursor is nothing. Okay, something must not be getting passed correctly, because once we're here, the Lexer it has 16 tokens left, and that was a mistake. Let's not do that. I think I was reading that wrong. So Lexer num tokens is 16. So let's use the watch window here, because Visual Studio is not going to be able to show me this. Lexer tokens 0. One, 2, 3. At this point, we should be at the external, though. So this should be the only... How are there 16 tokens left? There's 1, 2, 3, 4, 5. So I ask, how is there 16 left? The first num. Oh, because that's not moving. The cursor is where we're at. We're at 16, which means we are at. Okay, I was misremembering how this worked. We're at 16, which means we're at the end of the buffer. Why? Is it because we already skipped over? Let's go back here. Let's go back to here. Okay, so the parser's token cursor is currently at 14, which means we are at external. So if we advance by 1, why are we at 16? Oh, I don't think I'm lexing that properly, am I? Depend? Lex. Yeah, I'm not lexing this properly. Yeah, okay. Yeah, okay, the Lexer needs a special case for I guess we will always assume that these are one-line things. Man, that's... The Lexer shouldn't have to care about this, so... Actually, I guess preprocs are already like that, so that's fine. Let's say, we'll say this is declaring, or this is declaring something coming from an external header or library, so it can later be parsed without us having to parse that library. So for external, really, all we do in this case is add the preproc directive and lex like normal. So we add, is it preproc? Yes. Yes. We add a preproc. The directive is external. We skip over it. We skip white space and new lines. Don't care about this. We're just done. We back out and we lex like normal. There we go. So we hit this external. We should just parse this like a normal thing afterwards. So that just looks like a variable declaration. And hello. And that's where we're at. Preproc external. Okay, my mouse is going out. Why is that happening? Stop doing that. I need you to function. Okay. It's an external, and it's a variable decal called standard out file number. It's an S64. So that's actually great. So if I remove this, what if I grep for std out file number? This should tell me it can't resolve it. Right? So it doesn't know what this is because I'm not parsing any of the system headers. But with this external, now it should, because I'm giving it a place for that to live. Okay, it's not yet, but we're getting there. This should resolve to this node. Which it's not because okay, you know what? Actually, I think what I want to do is instead of making an external no, I do want that. I think what I need to do is I think what's happening is it's not going down one layer in the external to see depends on, although it should be, because it will go through its children automatically. That actually should be working. That should be working. Let's do this really quick. Let's create a case for the external here, just to give me a place to break. And let's just take a look. Yeah, so here's the variable decal that we made. This pointer should be here. It should be able to find it there. So let's see why it's not. This is in node depends on. Here's the external. Okay, so it's not even looking. It's not even looking here. Because that only looks at globals, probably. No. Oh. Maybe externals. Okay, hold on. When it's looking at the dependencies, it takes the type dependent list, which what are we comparing against, though? I'm confused now. I don't remember quite how this works. We make a copy of the type dependent list. Right, we only care when nodes depend on each other, because we've already determined everything that's type independent comes at the top. So we are not comparing this against the whole. Right, we are not comparing this with the externals at all. When we create this is not even where I'm looking. This is dumb. I need to look in the connect decal refs. That's where this is supposed to be. Find decal ref match upwards is what we're looking at. Right, yeah, that's, this is not the place. We need to be in connect decal refs, and let's say, okay, let's look specifically for that. So not here. We are in here. Do I still have that in there? Oops, we can get rid of that. Here. Okay. Let's find, I assume we just don't find this. No, we don't. So why don't we find this? We look at the parent. All right, let's look at here. Let's look at the parent. It's a compound statement, and then it's a function. So, all right, let's look at the source file level. We're looking in platform, it won't be there. Now we're back at the root. So now we should be looking at this. Okay. So now we're looking at the whole root. We should be looking okay, that's a confusing name. We're not really looking upwards at this point, but we're reusing the same function. So we search the name. So here we go. If it's a source file, let's go until we find where we know this thing lives. So it'll be that include file. So right here, we should find it in here. Search this AST for this. Okay. So here's what we're looking for. the AST. Here's the source file we're looking through. It's got 2 includes and an external. So this child is the first include. It's not going to be there. It won't be there. We should find a match here. So node match for string. Right, so in here. Yes, okay. Found it. So we're gonna say node match for string. This function needs to say whoa, what was that? That was weird. I've never seen that before. Okay, so if it's an external, then we need to do this on our child. It's called node, and this is string. Okay, so we need to match our child for that if we find one. Nope. Right, we need to return that. Still no. Okay, how about, let's just do what these things are doing. I don't remember quite if this needs to be done this way. I assume it does, I guess. If result, return result. And we'll also say if it has a first child, which it should, this shouldn't ever happen. There we go. Now we are connecting. That's really good. That's great. So now I should be able to grep for any unknown, so in any decal refs that didn't get connected, of which there are a lot. There are more than I think there should be. Like, I don't know why this isn't getting connected. That should be. But like file and line. Wait, why aren't... Okay, hold on. That's a little confusing. I'm not sure what those cases are. That's a... Oh, this is a... let's do this. So this is in platform, function call, line number string. What is this? I don't even know what this is. Let's have more context, please. If debug, if, what is this? Memory arena already initialized. Oh, is my assert a snippet? It is. So it's this. These aren't getting connected, and neither are these. So, okay. Those I can always insert. Okay, first of all, I'll save those for later. I'll come back to those. The file and line, like those things, are preprocessor things. I can special case those, that's fine. that's fine. Let's ignore that for now. So, I'm not sure where those are coming from. Let's look at any of them that are definitely coming from. It's like underscore exit. What is underscore exit? It's just a void. It's just like a function pointer, basically. So, I should be able to say external void exit, and it takes an integer. So I just declare a forward declared function. Let's see if that still shows up. It does. So those don't resolve. Not entirely sure why. Let's look at oh, first of all, it doesn't know what int is. These are all S64s. So exit S64. Okay, so that's fine. So why doesn't this resolve? Let's see why that doesn't resolve. Let's do exit. It's not where I wanted that. You go here. Okay. Where are we? Yes, so this should resolve, and it is not. So let's once again go up here to here, and the source file should be the include. Okay, so this thing has two include, this external, right? No, that's the variable. This external. Wait, is also a variable? That's wrong. Oh, that does look like... That should not be a variable. Excuse you? Okay, hold on. That's getting parsed as a variable for some reason. Let's figure out why that's happening. Next should be... Oh, that's the next one. Next should be exit. No, it's the void. Right, void. Okay. Start an expression, which it does. And after next is an identifier. Which it is, okay. After next is an open paren, so it should be a function or variable. Next is, okay, we're looking at the void. Skip ahead. We don't skip ahead at all. So after next is the exit. There's no special case here. So the type is a void. The next thing is the identifier. After that is an open paren, and after that is another identifier. So if the next type is an open paren, which it is, if we see a semicolon, we break. Right, we're looking for what the last thing is. So we see the semicolon, we break. Function decal is 0. Oh, we only... because we don't support forward declaring functions, because you never have to. So it does just think this is a variable. I hate parsing C. I really do. Is there a way for me to say, maybe I already was doing this, kind of. If the next thing is a parent open, and the next thing I see after that is a known type, it can't be a variable. That's what I was about to do. If it's a known type, or it's a property like const, it can't be yeah, so we're gonna say, hold on, as we're peeking through this, if we see an open curly, or if we see a known type, yeah, if we see a known type, it should be a function decal. But that makes us break. So one way to solve this is to just have you do that, which is stupid. Although, wait, why did that suddenly break? And also, why is... Oh. Wait, it still thinks that's a variable. How could you possibly think that's a variable at this point? What are you talking about? External, let's do that again. Skip the first one, and we'll go in here. Go in here. we should see a curly open at some point. Which we do. It's a function decal. Parse function decal. Okay. It's called exit. It returns a void. Great. So this type should be the S64, which it is. Yep. We skip over that. So this should give us a variable decal, which is an S64. That actually just works. So what's your problem? Oh. We fail immediately after. Why? Why? Okay. We see the S64. We parse a variable decal. Boom. We see the... We skipped one too many. Why are we skipping one too many? That's why. We're skipping over the close paren. If the next type is a comma... we don't want to skip over it if it's a closed paren. We don't even want to skip over it's the comma. The caller is taking care of that. Okay, cool. Caller is taking care of that. Great. All of this connects now. The only one that doesn't... There is one that doesn't. Why? Okay, this is the only one that doesn't, is the one that's inside of my crazy snippet thing, which I think makes sense because well, is this in the snippet? I actually don't know. Is this the snippet itself or one of the sites of the snippet? If def, so it inserted man, I really wish I had a better way to browse this tree because it's a little hairy. Where did my exit go? Wait, where did my unknown exit go? It didn't. It disappeared. Can I do this? Like, does it know how to do that? No. Do I have to like give me extended grep here? How do I do this? Alright, let's look it up. Grep or match. Or not and match. Alright, let's just look at all my exits again. This very first one. So let's look at all the unknowns. Give me a bunch of context. And also at this point, just search for exit. Give me all the context. That didn't work. Because I mistyped. Okay. Why is this just gone? Oh, it's probably just because it's going off the top. I'm showing too much. I am showing too much. Alright, fine. Let's just output the whole thing. And give an Emacs. Let's give Emacs a go at this. Exit. It's in platform. It's the very top. Yes, it's in the snippet itself. So, when we're in a snippet, let's just not output that we don't know what it is. We obviously don't know what it is because if we're not, what is it called? Snippet. In snippet body. So we'll only output this unknown tag. Here's what we'll do. We'll say we'll say tag. Are we in a snippet body? Then it'll be in snippet. Or like, I'll just say in snippet. Otherwise we'll say unknown. And this can just be the tag. And actually let's just go, nah, we don't have to involve that, it's fine. We'll just say tag. The reason I'm doing that is because I would like to know where they're actually unknown and not just, I don't care about them being in snippets. In snippet body. Do I not have that at the parser level? In snippet body. Okay. That can be graduated to parser level, I guess. In snippet body. Oh. Okay. Now we should not see that anymore. Great. All the exits are gone, I think, right? Let's grep this for exit. Awesome. So let's have one for right. Okay, let's ignore this. Let's say to do, we no longer parse forward declared functions, which is great, other than it complicates this external stuff. We can't just forward declare functions here. We have to include the empty, otherwise we think it's a variable. It's a variable decal. Make parsing more robust to handle detecting the difference between these two things, if possible. I would really rather not complicate this external syntax. I like how it's relying on the parser so cleanly. Okay, so let's add the other ones. So there's standard out, there's standard in, there's standard error, and then there's write, which is can these just be ints? Is that cool with you? Can I just say like size t write size t, or no, int const void and size t. Are you cool with that? Well, you still don't know what that is, but what if I do this? No, you don't know what that is. So let's see why. So instead of exit, we'll do write. Okay. So we try to find it. I shouldn't have deleted that. I want that there. Where was I? Here. Here. And then here. So this child's an include. This should be, so 1, 2, 3, it should be the fourth one that we check. 1, 2, 3. What? What? we look for right. We look for include. And then we look for the AST we're looking through is this source file, which is include. And its children are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, the fourth one. Maybe this didn't parse correctly? It's a decal function called write. It returns a size t. And it takes 3 parameters. The first parameter is an int. The second parameter is a void with 1 pointer depth and 8 for flags, which oops. Which is const. Yes, it's a const pointer to void. And its third parameter is a size t. Oh, I bet that's why. So, this child is the include. We don't match. The include we don't match. This first one we don't match. This next one we don't match. Why are we breaking out of this already? What? Why? Why do this? For each child of this. 1, 2, 3, 4, 5, 6, 7. Okay, we go in here. It's an include. Oh no, what did I do? How did I do that? I don't know if this is what's breaking it, but I somehow took that thing's break. I don't think that's causing the problem here, but no. But that's at least, that's causing a problem at the very least. That shouldn't be like that. Okay. This child is include 1, 2. Why do we stop at that point? Oh, why? We just stop. Okay, well, let's just look at the whole tree really quick for after, let's just do 50. So we have an include. We have one external, which is this, another external, which is this, another, which is this, another, which is that. That looks fine to me. And that. So that looks fine. Why are we... Get num valid children. Is there something wrong with that? No. That's so strange. Why are we just stopping? Hello? There's the first include. We don't match. For each child node of this. So we just looked at this one. And now we're looking at that one. And now we're looking at this one. Okay. We don't match. Okay. Now we're on the next one. Why? I'm so confused. What are we doing? Okay. This one. What do? We hit. We found a match, actually. That's what's happening. Am I looking at the wrong thing? What is happening right now? We're trying to resolve right. So now we're here to compare. I am totally looking at the wrong thing. We're trying to resolve right. So let's find the match for that upwards. Oh, it's because we're resolving the the things we passed to it first. I just wasted a lot of time on that. Connect. Search. Where do we do this? Search AST. So I want to look for when we're looking for right specifically. That's what we're trying to resolve. So right, because we're going, yeah. Right there where it says we do our parameters first, that's why we're getting intercepted there. I want, okay. I want this to actually be here. Connect decal refs if child. not child. This is AST children 0. Okay, that was a waste of time, but we're good. It's all good. So now we're here. Yes. So now let's do that. We don't have any children. So find and connect declref here. And the declref that we're connecting is this thing called write. For the first parameter in a function call or the declref. Okay, that's a bad name. That's not parameter, but okay, that's a bad name. If we're the first node, if we're the first child in a function call node, we're the first child of a function call node. We can search for the function decl by name. So we search for each one. Okay, do we ever find a match for by name? We do. We find it by name. Here's where we are failing probably. So the function decl that we found should be our external one, which it is. So that's good. We found it by name. We're failing on the parameter part. So do the number of parameters match? Let's go here. The call param count is 3. The decl is 3. So that's fine. We're good there. So now we're going to compare each parameter. If the function decl param type, it should always be a parameter, so that's fine. So the reference parameter is our declref, which is stdout file name. And our function decl type is an int. Okay. So the thing we're trying to compare with is a declref. So let's call this again, but do it with what we're pointing at. So now we're pointing at a integer variable, and we're comparing with an integer variable, so those should match. Comparable type string, so the ref param type and the function decl type are both int. We fuzzy match. Great, so we matched on the first one, so I think we're failing on the second one is what's happening. We're not matching, I believe, this const void star. Oh. Right. Of course we're not matching on that because we're passing in a const char star. Fuzzy match. If you take a void star, I should probably fuzzy match on... Okay, before we go any further, let's just verify that's what's happening, but I think we should fuzzy match on void stars. So I think that's what's happening here. So our second one is a void. A flag of 8 means it's a const. and it has a pointer depth of 1. So this is a const void star. Okay. And we're matching against something called message, which is a const char star. And that is not going to match. Yeah, that's not going to match. So when we do a fuzzy match, well, I guess in this case, I'm never calling right with anything else. If this is a char star, do we just work? No, we still don't. Because this last thing probably won't be a size t either. This is going to be... So we need to make these look like what my program is expecting them to look like. So we give it an S64 for both of those. Yeah. Yes. Okay, that makes sense. This is my translation from where they're coming from to what my program wants to be passing to it. That's fine. I'm okay with that. So let's look at read. Same thing. Even though I'm not doing that yet, so actually let's hold off. So actually, first of all, let's add an assert to say where would we do that at? Let's say I guess the very post pass, like at the very end. Or really, at the end of any post pass, I guess we shouldn't expect to have anything. Look for any decl refs, and if that node has not been resolved, what is it? Exit, early exit program? Yeah, just early exit program. And we will say, right error. Don't I have like a, yeah, report error and exit is what I really want to do. And it's going to be on that node. It's going to say failed to resolve decl ref. So this will definitely fail. Like absolutely. Failed to resolve decl ref, but I want it to show me the node, so that's the location info. What if I do like let's be more specific. We'll say write error failed to resolve decal ref node source location info node. I don't know what this is gonna do. Is that enough? So that's that. I want to this, that, and then finally print node nicely. Node true. Expression in snippet at. Oh shit. I also need to know here that it's not in a snippet. You know what? How about instead of, how about we still give those a pointer? We're just gonna not we're gonna say if it's a decal node, no, we'll just stick with this. I don't like this though, because this is like slow. I don't want to have to do that every time. I need to cache the fact that it's in a snippet. So let's cache it. Let's say if the node is in a snippet, it'll be one of the flags on the node. In snippet. Okay. Node is a child of a snippet, which has special rules. So we'll say instead of this, we'll say tag is we'll keep doing this back the way we did it before. If node flags, node flag in snippet, we will do this. If it's not in a snippet, then see if it has a node. If it doesn't, we don't know what it is. So over here, I can say if not node flags in snippet. Okay. And then finally, I guess for the, can we just do that in the post pass? Update snippet. Replace snippet calls. How about when I parse the snippet? Where do I parse snippets at? Oh, we just do this here all the time. So anytime we what is the best way to do this? If our root you know what? Yeah, this is a bad place to do this. Bad place to do this. This will be in the post pass. We'll do two things. For each snippet, for each child of the snippet, we will just add the in snippet flag to the node. Fine. These are node flags, node flags, node flags. Okay, we compile again. Did this actually work though? No. So for each snippet, for each child of that snippet, wait, we shouldn't be compiling. We're asserting. Okay. There's all those. So why is that not working? We are setting their flags. So here, for each decal ref, expression at platform line 4. Right, so this is in a snippet, so it should oh, stop doing this for half a second. Okay. Yeah, we're in a snippet, so all of these should have their, these should all say in snippet. So why doesn't it? because, okay, because that's not recursive. We're just looking at their children, not their children's children. So the snippet node is the node, and then for each, in the snippet node, for every decl_ref in there, we need to give it the in snippet thing. Yes. So now these are all in snippets. They are not going to be unknowns to us anymore. So now when I print this, we shouldn't see anything that's like inside a snippet. These are the expanded snippets. So these are the snippets that got expanded. Those should be linked up. So that's the next step, is to start linking those up. If I turn this back on, we can just start taking these one by one. Let's get rid of the failed to resolve decl_ref. Okay, let's do this. Failed to resolve decl_ref. At that. At this. Oh wow, 4coder is having issues today. That's so weird. I've literally never seen that happen before. Failed to resolve at that, and then we'll say I don't need the whole thing because I know it's not resolved. Yes. Okay. Failed to resolve decl_ref. In fact, let's just consolidate this whole thing and just say forget all this, and we will say this. It's a little verbose, but that's fine. Failed to resolve decl_ref expression at that location. Looks good. So wait, we're still failing at platform. Oh, because I removed the other check. Not node. If it's not the case that node flags, if that's not true, and that's not true. Now we're looking good. So at 57 in platform. So this doesn't resolve to a C string, and what is C string length? A U64. C string and U64. Right, because it's S64. But that should fuzzy match. It's a little confusing, although I don't know why these are S64s. You never pass a signed value to this. That should match now, which it does. But that should also fuzzy match, because that will in fact compile, so. Fuzzy match. Matches string, boolean, matches number. Matches integer type. That should have matched. Okay, before I go changing this, I need to see why it didn't match. Because that should be matching. Failed to resolve. No, that's not what I want. I want connect declrefs. Where was I? Connect declrefs. It is a function call, and it is this. I want this, and I want this to be that. Okay. Let's go. This should be on line 57. So let's say AST line number equals, what did I say, 57? 57. Okay. So for each child, the first one's the name, we skip it. So for this declref, we should connect up to message, which is a const char star. That's just the parameter. So after we do that, our first child should it doesn't at all. Well, that's a problem. So now we're looking at message. We have no children, so we do us. Declref, let's find it. Search AST for declref match on message. And we should find it pretty fast because our parent is a function call. It won't be there. That thing's parent is it won't be there, but it will be in this decl function, right? Its only parameter is message. That we should match to that. So node match for string. This node is the parameter. It's not a function pointer. Does the name, node, info, variable, name is message, length of 7, equal the string. And the string is message. Those match exactly. Okay, we matched. We did find it. We found it. We found it. Okay, so we do connect it. So this node, message, we did connect it. So what happened? Okay, we did connect message. I don't know where I got that we didn't before. I must have just misread what we were doing. But this next one we're obviously not. So This next one is a function call, so let's go in here. Skip that. So, again, message, we should connect that, no problem. So, this child is message. And we found it, okay. Great, and now we do us, the function name, which is this thing. It has no children, so we do us. Okay, we are now looking for C string length. We know it's a function, so we need to look for the function by name. And the name we're looking for is C string length. What? Why did we just skip that entirely? The AST is... Oh, duh, because, okay, we're not looking in, okay. I need to go, here until the parent is, we expect to find this in, wait, what? We expect to find that in cstring.db. So, I don't know why that didn't show up in the search, but so we need to wait until we're looking through source files. So there. Nope. Did I? Are we still? Shit. Arg. I've messed up. So do our parameters. The first parameter's fine. Second parameter, boom. It's a function call, so skip that. Are we back? Nope. Yeah, actually we are. Yes. Okay. Connect the child. Did that work? Yes. Okay. Now we do us. This is what I wanted to do. When we go to find it upwards, this here I need to wait until the parent is the root node. Okay. So the parent is the root node. Now we're going to look through the entire AST for this at this point. Or no, not yet. Now we are. Parent is AST root. Here we go. Now we're going to say are we the first? No, we're not. No, we are. Yeah, we are. We're the function. So we're searching for it by name in the root So for every function in the whole program, write output. Let's put a breakpoint here. Write notice, write warning, write error. We're looking for C string length. And just to verify, we're still looking for C string length. So let's do this. Let's just verify. Let's open this watch list. We are looking for the declref info expression declref decl name. Just make sure that that is always C string length here. And the thing that we're matching against is the node info decl function dot name. So write exit absolute value, create string builder. There are a lot of two strings. How about we do this? This we'll say as long as it's name 0 equals C and name data 1 equals S. There we go. Okay, so we should have a match at that point by name, which we do, so that is a match. C string length. Okay, let's compare the parameters. Let's compare the number of parameters. 1 and 1. For each child, it's a parameter. Okay. The function decl type is a char star. Is that right? It's const, but does that matter? I don't know. We'll see. Maybe that's why. Char star, and our ref param is message, which is a const char star. Is that going to matter? Let's see. So ref param type is char star. Function decl type is char star. We fuzzy match. Okay. We matched. We found the function. C string length. We found it. Here's the function call. We found it, C string length. Wait, what am I lost? Message, yeah, it found it. Oh, but now it's not fine. Okay, hold on. So it found the parameters for this. It found this. It knows what these two parameters are, but now it can't match up with this, even though it knows its parameters. Why? Let's see. So function name. Okay. Now we are looking for Linux write output. So same thing. Let's go back here. Let's change this to Linux. So we are looking for Linux write output by name, and the one we're looking at right now is called Linux write output. Okay, we found a match. So let's see if this is the right one though. So our function call, we're passing it two things. We're passing it a const char star, and we're passing it a U64. So we should be able to find const char star this. We're finally at the point where we're trying to match against this. Const char star, this should fuzzy match. We should be good. Why is it not? So, number of parameters, we're good. 2 and 2. We are now comparing message, to which is a const char star with, so if ref param type is a decal ref, okay. So now we're comparing the decal param, char star. Those match just fine. Cool. Okay. Next one should be an S64. Function name with return type exists. Oh wait, we went to a different place. Hold on. Oh right, because this is a function call. Function name with return type exists. The decal type is an S64. The name is C-string length. Is there a C-string length function that returns an S64? No, it's a U64. Oh, I bet this function doesn't fuzzy match though. What do you want to bet? No, it does not. Haha. Haha. With return type exists. This should be a fuzzy match. Fuzzy match. Function decal if fuzzy match function decal type and this. Now we probably work. We do. Okay, getting there. Grep unknown. We should be down to how many? Oh, because we're still failing. Let's not assert there for a sec. Actually, who cares? I don't care how many there are left. I just care that they're happening. So memprotect none. Let's do that. Wait, memprotect none. That's my thing. Why is that failing? That's my thing. Hello? Okay, let's have this on a toggle until I get this figured out. Memprotect none. Why is that the case? Let's look at platform. I need more than that, don't I? Yes. Okay. Yeah, it just didn't find these. Why? Memprotect all is a const u8. Wait. No, it does have these. Hold on. What are you complaining about? Memprotect none is what it's complaining about. If protection... Oh. Is that in memory arena? If protection... Here. It can't connect this. Okay. Why? Connect decal refs. We're gonna say if ast type equals ast expression decal ref, and the name is memprotect none. Let's do this all over again. Connect. This needed to happen a long time ago, so even though this is horrible and tedious and annoying, it's really good that this is getting done. This is gonna shore up like so much stuff. Okay. So for each child node. Wait. What? Oh, that's fine. We have no children. Let's find us. Do we find us? We don't. There's the problem. Find decal ref match upwards. Search AST. Search AST for decal ref type. We're gonna look at the operator, the if, the compound, the function, the source file. Okay. The root. And then find in the root Wait, what? What? In the root, we're going to look for. In the root, we're going to look for memprotect none. So we're going to find wait. If declref search AST for declref, we're going to look in AST. I'm confused why we are. Oh. We just start small and expand upwards. Although, didn't we just do that? I'm confused. We just did this. Okay, that's weird. But yeah, we're going to start at the declref and go upwards. So, once again, we stop here until we are what? Hold on. I need an easier way to go through this part. This is kind of a nightmare, and I don't like it. Stepping through this code is just kind of sucky. Okay, so we're looking for memprotect none. And we're looking for it in the source file that is platform.db. It won't find it in here, so it's going to go up one more. Now we're in the root, so let's search in here. Search AST for declref type match. So we start there, and we start at us and go upwards. So our parent is the binary operator. We're not going to find it in there. That thing's parent is the if. We're not going to find it in there. That thing's parent is the compound. We're not going to find it there. The function. So now at this point we are searching in. We looked here first in this binary operator. It's not there. Search for it in the if. It's not there. Search for it in this function. It's not there. Searching for it here, because like it might be up in our parameters. It's not there. So now we're looking in this whole source file. It's not going to be there either. Now we're looking in the root of the whole part. We're looking at the entire tree at this point. So for every source file, I want to stop on where we know this thing is, which is in platform.db is where this is. So right here, we should find, we're looking for memprotect none, and we should find it in here. So why don't we? For each child node of here, this is the struct. It's not going to be in the struct. In the variable decl for platform API, it's not going to be in there. in the arena temp variable. It's not going to be in there. It's going to be in here. This is the variable for API memory protection. Oh. We're not even... Oh, because it's not an enum, is it? I have a separate thing for bit fields, don't I? Doi. I am not recursively... So, this language has a keyword bit field, which behind the scenes is just an enum that automatically increments your things by powers of 2. But because I tag it as a different thing, I need to give it, I need to tell it here, ignore forward. This needs to happen for bit fields also. We compile. Oh, I didn't remove the assert, or I removed the assert, so let's go back to failed to resolve. Still doesn't find it. Okay. Thought we were going somewhere with that, but we didn't. That's okay. We'll get there. Why not? Failed to resolve. Wait, that's 65. Yeah, we still didn't. Why not? This can go here. And then here, and then here. The AST is the root, the child. Let's once again look for platform. Damn it. I found it and then I skipped over it. Okay, search AST. This is the struct, variable. Wait a minute, that's a variable? Hold the phone. This shouldn't be a variable. I didn't even see that. This source file has a bit field. Why did I not see it? This variable is temp. It's not that. Bit field. It's a bit field. Does the name equal this? It's not the name, but its children should. We're looking for memprotect none, and this child is memprotect none. That should have found it. Why did it not? Child, name, memprotect none, 15. To compare, memprotect none, 15. Well, that's the problem. So this one more time. Okay, bit field. Boom. Boom. Okay, so the child in this case is memprotect none, and we're looking for memprotect none. Oh my god, do I have a bit field member also? Arg, I do. I never updated that. Man. That's scary. I have to add this stuff in multiple places. That's really error prone. Bit field member. Okay. Oh, I need to once again. Let's add the. Now we should have found it. Yes, we found it. So how many are we left with now? A lot still, I admit. That's still a lot of unknowns. But that's okay, we'll get there. Should I finally handle those? That'll knock out a decent chunk of these, because these are preprocessors from C that I can just hard code in. Where would I do that at? In connect declrefs, I guess. So connect declrefs. Connect declrefs. If it's a declref and the name is let's see. Flex, parse, and run. So don't need to do that. So when we run the let's just do it on the post pass. Fuck it. No. We will do it on the post pass, but I need to insert those nodes first. So the problem is, these need to point to nodes. I mean, I guess those can also just be externals. Yeah. I think. So common, right? Can't this just be an external S64 line? External const char star file? Yeah? Maybe? Oh, that knocked us down a lot. Okay, I'll just do that. Screw it. If you want to use those, you just have to tell it that you're using them. That's the simplest, I think. So, protection none, protection exec, protection read, and protection write. Protection read is in Why can't it look... Why can't it find that? I'm confused. It's probably in platform. Wait, or is it in memory arena? No. Wait, what is it? Protection none. Oh, that's in the Linux part. Yes, those are coming from Linux, right. So, protection exec, read and write are flags, which are just U8s, I guess. Linux platform, so Linux include, we will say external U8. These will all be S64s. No, U64s. Let's be consistent, huh? Right will also be a U64. And this will be a U8. Protection, what was it? Read, write, and execute. Exec. Read, write. And none. Oh boy, it's coming down. mmap. Let's just grab both of these. And we'll say external. So this is a void star mmap. It will take a U64. It'll take a void star address. No, wait. I'm using 1, 2, 3, 4, 5, 6. I'm only using this one, so void star U64. S64. No, these are flags, so we'll say U8. These are also flags, so we'll say U8. This is a file descriptor, we'll say S64. And an offset, we'll say U64. Oh. Oh, I'm not done with this. S64, U64. This is a void star. This is a U64. No, I don't need that. There. Why is that still happening? Include 24. This is failing on something. It doesn't like void star? Oh. These are functions. That's annoying. I don't like that, but it is what it is. That's what this big to-do up here is for. I have to tell it explicitly these are functions by doing that, but okay, it still doesn't know what mmap is. Why? I'm passing it a... Oh. How about 0? The first thing is an address. Right, so if I'm passing it... Okay, what if I externalize null that? No. Okay, we'll leave that one for a second. We'll leave those. Map private, map anonymous are more flags. Memory unmap is fine. Push size, Linux write output, format string specifier, those are all mine. Care, that should not be a thing. Wait, what? Okay, we're down to everything being mine except for we're down to all of these being my stuff except for unmap and wait, where did mmap go? That's working now? What do I do? Oh, I got that to work. Oh, yeah, I'm only, okay. Okay. I mean, that's not good. Those should match. Okay. Void star should match any pointer type. So let's actually leave this broken. Let's leave that that way. Okay, so besides memory map and unmap, all of these are mine. So let's just start seeing which ones are failing, shall we? Let's go and turn this back on. Okay, actually, let's leave that unbroken so we can skip past it. String builder 35. Oh, this is in the assert. This is expanding the snippet. So assert assert here. It can't resolve this, I'm pretty sure. In fact, we can see that if we only do that one. It's not that one. Wait, which one's failing? That one is. It can't figure out what message is. Message is coming from the calling scope. No, it's not. Never mind. It's coming from the snippet. It can't resolve that. But it can resolve that? Okay. Let's turn this off again. Figure out why that's happening. Let's print out the tree. Actually, this is too hard. I'm just gonna print out the tree. So this is in, oh God. These two around it do though. This thinks I'm passing a 0 to it. Literally thinks I'm passing a 0 to it. It thinks this is a 0. Wait a minute. It is a 0. This is a 0. Because I'm calling assert, which passes a 0 to it. Linux write output, which should pass a null pointer to it. Fuzzy match. To the rescue again. If so the problem is, if it's a pointer type, I should be able to match with 0. Matches pointer type. Return contains. If it contains a star, then it's a pointer type. Or if it's 0. Or no, just if it's an integer, right? We'll just match on integers. Oh, contains character. If this or this. Still doesn't. This is still failing me. Wait. Oh, God, I'm like, what is happening? This is a sign I've been staring at this for too long. So, it can't resolve this one because I'm passing it a 0. So, ref param matches. Okay, you know what? Let's undo what I did before. Where was that? Fuzzy match. Let's undo this pointer type thing, which I wasn't even calling. Matches pointer type. Okay, that still didn't fix it anyway. So yeah, I'm gonna undo that. I don't like that. I didn't think that through enough for implications for that. So what should really happen is here. we should say ref param matches. So if the decal param if the function decal param okay, great. If the function decal param info decal variable dot pointer dep, so if this is a pointer and we are an integer, so if the ref param is, if we are a literal integer, then if it's a pointer and let's not do this here. Although we have to do it here because okay, if it's a pointer, then if the ref param if it's an integer or a character, we match on that parameter. If it's not the case that that's true, then we also need to see if it's a function call. Let's just start there and see what happens. That fixed it. Does that break all sorts of other things? I don't really know. I think we're okay. If the parameter is a pointer and we're a character or an integer literal, we match straight up. If I passed you a 0, for example, we match to a point thing expecting a pointer. So I feel okay about that, I think. So let's see how many we're down to now, because this time I do kind of care. Grep unknown. We're down to 18. That is, we're getting there. Turn this back on. Push size at string builder. Line 65. So why is that? So we're calling push type, so we're calling this, and then we're calling this, and it can't figure out what push size is. So let's just look at the tree. Always look at the tree. Are there any push sizes that we know? No, there aren't. So this will actually fix a few of them. So this is in an if. There's not a head on the builder. We create builder head is equal to push size arena to use. So we can't figure this out. Why? We know what arena to use is. It's size of. We don't know what size of is. So push size wants a U64. So we will say external size of is a U64. It's a keyword though. I don't know if that's gonna work. I don't know what keywords are gonna do to this. Doesn't like that at all. Keyword. Okay, what if I just treat size of as a function call? Huh? No, that's gross. I don't want to do that. It's not a function call. It's a keyword. Or is it a... Maybe it is a function call. Let's just see what happens. Lexer size of. Let's just say, what if we say this isn't a keyword for now? And instead we say it's a function that... No, because you can give it any type. Yeah, okay, let's not... We've come this far, let's not be gross about this. Size of is a keyword. What other keywords are like that? Is that like the only one? A line of, size of... Okay. Maybe I can say in CodeGen connect types. No, connect declref. So what is it I'm connecting here? What am I actually missing? I'm trying to figure out push size, so I need to know the type of the function call to size of. So it is, according to this, a function call. I just need to hard code that that return type is always a U64. What if I do that? I'm gonna guess no. I'm gonna guess that's a big fat no. Yeah, we don't compile. Or we don't finish running. What about that? You okay with that? No. It does. I can't use a keyword there. It literally will not parse that. So find. So if it's an expression, declref match. So the problem here is, in this special case where it's a function call that calls size of, Can I not just match a special case here that says name? So by name. What if I do this? If I see that this thing's name is size of, can I just like stop? No. There I can though. So if we have a function call whose thing is size of, I need a synthetic size of node on the AST that I can point all of these to. That's the cleanest way to do this. I need to insert a synthetic size of node into the AST. So and I guess I'll just do this on the first one. Insert synthetic nodes for certain keywords to resolve to. Okay, let's just parser AST children. We'll say insert synthetic keyword nodes parser. Actually, we'll just give it the AST. Okay. And we'll just do that up here. Insert, and we take the AST. All right. Say size of node is create child node in the AST. Assert that we made one, and then this will be a function, right? It'll just be a function that returns the U64. That's all it has to be. So we do need the parser, actually. So we will create on the AST an AST decal function. I don't care about the line number. This is for size of node info decal info function. So name, size of, and return type. This is all I care about. Name is size of, return type is a U64. That's all I really care about for this node. And that's it. And for good measure, let's say it's external. And then we'll just say, so the thing is, in this case, I want to be able to just pull this. I want it cached on the parser, I guess. Synthetic node cache. So this will be size of node. Parser size of node is size of node. So in this case, I can literally just connect decal refs for this thing. If it's size of, it's t children 0. I can literally just say this is the parser's size of node. I think. These are all decal function dot. Okay, we didn't freeze. Push size. That works now. It knows how to find it now. Because this keyword size of. So this doesn't have to be connected because we always resolve size of. But I don't want this unknown in there. So let's have another like this. In snippet body we can say in keyword function call, and we can just say if we keep going and one of our parents is finally a function call, then return whether or not node's first child's type is an AST keyword. This is an expression. So in snippet body, in snippet else if I'm gonna say if not exempt from unknown tag, node, we'll print out that in snippet body. So we'll just have an extra one here so we can expand this later if we need to. Exempt from unknown tag. Return. For now it'll just be this one, and keyword function call node. So that should get rid of that. You know what? Let's just do this. Because this logic is a little more complicated now, so we'll say that. We'll say that. And we'll say that. Great. So we don't care that that doesn't resolve. It literally doesn't matter because we're calling a keyword. Okay. Now what are we down to? We were at 18 last time I checked. We're down to 14. Oh boy. We're getting there. I'm gonna keep saying that until it is no longer true, until we are there. So the next one, unable to resolve declref at string builder. I need to skip over this. So if we'll say exempt from unknown tag, we'll include the in snippet body as well here. And the reason for that is because we will also use that when determining this. No, because the whole point is I didn't want to be doing that, but I also don't want to cache that. Because this is just a simple check. Okay. Let's not do that. Let's instead say it's not in a snippet and not in keyword function call. Fine, let's just do it. Let's just do it. Let's just be a little little lazy. We got past it. Let's just be a little lazy. It's okay. In fact, let's say to do cache, find a good way to cache all of these things we're checking. So see, now I have a to do. I can move on and not feel bad about it. That's how to dos work. So absolute value, short string 141. It can't figure out this. Absolute value of an integer. Oh, no. This can't happen here. Of course it can't resolve that. It's a function that hasn't been generated yet. Oh, crap. Okay, if we remove this, okay, let's remove that, check. So now we do compile. If I look, that absolute value I don't think will be one of the unknowns. See, they are all actually connected, but not at that point. At that point, yes, it's unresolved, but it's only unresolved because it's a function that we haven't generated yet. Okay, so let's move this out of here and instead to the very end of this. So this is going to be in parser in the whole AST. We'll check this right at the end if there's anything that, although at this point we don't care that they didn't resolve because we're done running the metaprograms. The whole point of this is that the metaprograms don't fail when they try to resolve things. This is tricky. Okay, let's remove this for now. We'll come back to this also. And let's just see where we're at now. We'll just see where we're at. So that's being generated, that's being generated, that's being generated. This is being generated, that's being generated. These aren't, so we can figure those out. These aren't, we can figure those out. And okay, these aren't being generated here, so we can figure out these. These are all things that are generated by the metaprogram, and we will have to figure out what to do about those. And I don't know what that is yet, but we can move on. Let's figure out why float to string is not a thing that it's resolving. It takes a you know what? Is that why? Is it because that's optional? Is it because these have optional parameters? Is that why? Okay. Just do this. Why overcomplicate this? Okay. If that's why, I'm both hoping it is, because it means my code is working. Okay, it's not, but I'm hoping it's not because I don't want to not support optional parameters. So that didn't actually work still. Okay. In toString 128. Oh. It's just that. Oh. I know why that's not working. Let's go back to fuzzy match. I never upgraded this to know what a float 128 is. Okay. So that's fine. But why is int to string? It's just the one that takes value.value and value.base in print helper number base. Print helper number base. This one it can't resolve because it takes a U64 and a U8. Int to string. U6. Oh. No, it is what I was saying. It's because it has a default parameter. Maybe? Maybe not. Hold on. That may be premature. That is premature. So why can't it resolve that one? Okay, so now can I put these back to having default args? I like being able to have those. And right now I'm not thinking if that's a problem. I'm not thinking through those ramifications. Okay, no, we're fine. Okay, int to string. Why is that not resolving? It's a function call that takes a... It should know what that is. Oh, it's actually thinking that's... That's interesting. Okay, what this is doing It's because these things have the same name. Value dot, this is value dot value. Here. Value dot value. When it goes to match this name, it's matching it against this as well. Which is stupid. It should, if it's a member ref, it should be looking at its definition, where it came from. So connect decal refs. Upward. So we'll say, if we're a decal ref, then if we don't have a node, before we do anything, if we're the right-hand side of a member ref, start our search at the definition. Do a quick search of our definition before looking elsewhere. If you're a member ref, you shouldn't even, it's not possible to come from anywhere. Search our definition. If node parent type equals AST operator member ref, then what we want to do is, so let's do this. Instead of this, we will search in node parent children 0 so if our parent, I think this is all we have to do. Uh-oh. Well, we broke a lot of those, and we didn't even fix that, so if we're a member ref, if our parent is a member ref, and we're the right-hand side, sorry, I didn't do that part, node equals node parent children 1. If we're the right-hand side of a member ref is what that first part does. Still broke that. And this should actually be search AST for declref name string. So we're going to search that for node info expert declref dot decl name. Oh boy. This is still connecting to the wrong thing. So let me make sure we're even hitting this. Node nicely, node true. I don't think we are. So instead of that, how about we print this name plus dot plus this name value dot value is right there. Okay. You know what? Let's just do a thing here. If name equals value, and we'll just do the same exact check. So if it's value dot value, let's just break. Value. Let's get rid of all these. Okay. So search the decl param. Oh. Right. That's not what we want to do. We want to go all the way up to the source. Because this decl param has a type node. That's what we want to get to, is this type node. Get to declref from memberref. Get to type is there a way for me to get type node? No. I need to be able to get to a type node given a node. Like up the tree. I don't think I can do that easily right now. So I basically want to say this is a decal ref. So if I'm the right hand side of a member ref, I want to get to the thing that I'm a member of. I want to get to that node. Containing struct. Get containing function. How about get containing struct of the node? If containing struct, let's search the containing struct for me. Get containing function. We'll have get containing struct. While no, okay, let's just say this is not Vim at all. This is forecoder. If you look down in my description, you can see a link to forecoder. It's primarily a C++ text editor, but the community at this point has made it work for more things. So I'm basically using it for C. I'm just using VS Code for the debugger because I haven't found a better debugger on Linux for a visual debugger. So yeah, for debugging, I just use VS Code. Yeah. So it's a decal ref. So while node and node type not equal AST decal struct, node equals node parent, or no, we're saying containing struct for member for right hand side. We'll make this very specific. Right hand side. We're going to assert all of this stuff. We'll say is right hand side. Okay, we'll say this. And we'll say if is right hand side, and there is actually something on the left hand side that we can check for. So, okay, we're saying for a decal ref, and we haven't been resolved yet, if we're the right hand side of a member ref and we do in fact resolve on our left hand side, get the containing struct for this right hand side. So let's assert this same thing, that node parent, or let's assert that is right hand side, and let's assert that we do in fact have a resolved left hand side. Then so let's also assert that we are going to have to be Well, we are either a function call or a decal ref, right? So node type. Okay, let's do this. This and this. This is going to be node type equals expression function call, or we are either a function call or a decal ref if we're going to be a member. So so if let's start out. Let's assume that we're a decal ref. Forget function calls for now. That's just going to complicate this. So if we're the right-hand side, then here is our resolve equals, we'll call left-hand side is this, resolve equals left-hand side, while resolve, and resolve type is not a struct, resolve equals resolve decal info decal ref decal node. So we'll just follow it all the way up until we hit something that's not a thing, or we hit our struct, I guess. 141. Oops. Where are we? What are we not seeing? Unable to resolve type for parameter. Oh, wait a minute. Unable to resolve type for... Oh, wait, I'm in here now. Unable to resolve... I'm here. How did I end up over here? Let's see. Find and connect. Let's just see if we're here. Do we ever get here? No. Which means we broke something else. So if I just remove all this, are we back to at least not failing? Yes. I don't like this heuristic here. It's gross. Yeah. There's not a lot of stuff written down yet because I'm still working on a lot of it, but this basically started out as just a C parser because I wanted to do some metaprogramming, so I started just writing a C parser. But once I had that working, it very quickly ballooned into, oh, I can kind of add whatever I want. So it's kind of turned into its own separate language parser. I basically have these .db files that can do all sorts of metaprogramming. So there's basically, like, when I compile, it compiles the metaprogram, which is written in C. It runs the metaprogram, which does, you can see here, I can print out the tree. It just creates a tree for your whole program. Here's my whole program in tree form. And what the metaprogram does is it takes this as input and you can do stuff to it. You can loop over it. You can add new nodes to it. So like, for example, here's what a metaprogram might look like is you can basically, it's a function you define, it's just a C file, and it implicitly takes that tree as a argument. So you can just do stuff like loop over, for each node, for every struct in my whole program, do some stuff. So in this case, I'm looping over every struct and generating a toString function for that struct type and emitting a function for it. And if you look at what that final thing looks like, so here's all those functions. These are all generated by the metaprogram. So for every type in my program, every struct, it's generating these toStrings, for example. And that's just this function right here is what's doing that. But then I've also extended that. I haven't decided that yet. I'm still deep in working on it. So whenever I get this to a point where it's not just like hobby grade stuff, I might start sharing it. I'm not against opening it up. I just haven't gotten anywhere near there yet. Still a lot of experimenting happening. But what's cool is, so that's like very explicit metaprogramming. I've also opened that up to the language itself. So I have like this any keyword or this any preproc that you can basically define a function that takes anything. So like you can say any and then like arg. And now anytime I call this function, I can call it with a string. I can call it with an integer, right? And if I run this and go look at this again, so see, it generated that test function with a C string. Oh, I guess that also did it with a C string. I'll have to figure out why that didn't do an integer version. It might be somewhere else, but anyway, you can say any, and it'll generate it based on the call site. And I also support this ellipses, so that'll expand into. So if I do that, now that'll generate one for both. So now it generated one with the single argument that I passed, this C string, and it also generated one with both of them, which is nice. So all that in mind, one of the things that I've done is create this print system. So if I want to just print out like this, right, this will just work because I have a print function here that takes one of these any ellipses and will do that for me. I'm going to stop printing the tree. I don't need to be doing that. So there's that. And normally when you do a printf, you have to say like a string or you have to tell it what type it is. But my metaprogram knows what all the types are. It knows what you passed it. So using the metaprogramming, I set up a whole print system, so I can just pass it a number here with just a %. And like it knows what that is. And that even extends to structs. So I can be like my struct, which has a string in it and a U64. And let's just say it has another like substruct in it. If you just joined, I'm kind of in the middle of explaining one example. I can go over this again really quick. But so if I have another substruct that has another string in it, so let's just say I just made up those two structs. So let's make a couple of them. Let's instantiate some. A is hello 1024, and we'll have it have another substruct in it that's just world. So I didn't write, I just wrote these two structs. I just made these up, right? So I just made these up here. I didn't have to go write anything. I can just say print %in. I can even say like my struct is, and I can just pass it a, and boom. So my struct is, it puts these curly braces when it's a struct. And again, the metaprogram knows what all the types are. So it can just recursively go through and say, okay, I'm printing out this member, this member, this member is another struct, so it's more curly braces, that member, right? So I'll basically never have to write a print function again, for example. It just, the metaprogram knows what my types are, it knows how to print them out, and we'll just do that, right? So that's like a super basic example of, for that functionality, I need three things. I need this print function, which the metaprogram is generating. It calls format string, which is actually turning this with a parameter into an actual string that's printable. That's up here. Format string, again, it just takes a format string and any number of parameters, and it builds a string out of that. And that specifically uses toString, which is the important part. That's the thing that takes a type and gives you a string out of it. To support that, I wrote toStrings for all the basic types, right? Any fundamental type I have a toString function for. But then my metaprogram goes through all the structs, and guaranteed the structs are going to just be made up of other structs or fundamental types. So it generates the rest of the toStrings for my structs. So with those three things in place, I have toStrings for all the types, I have a format string for any type, and a print then for any type. So it, like, down the chain, it just kind of works, and you can see I generate the metaprogram in these chunks. So this first chunk is like the first layer. So it's like, oh, I need a print function that takes an int. I need a print function that takes a myStruct. But these themselves call functions that need generated. So the next run of the metaprogram says, okay, that needs to generate more stuff. So here's where those are generated. This needs to generate this format string with a S64. It needed to generate one with a myStruct. But this calls toString on a myStruct. That doesn't exist yet either. So there's, in this case, there's one more layer that generates, although wait, where did that show up here? I guess that generated it here. That's interesting. I wonder why it generated it there. Well, that's a really good question. Why did it generate it there? It didn't actually. Okay, that's confused. I'll have to look at that. But so there aren't, the way I'm doing this, it's mostly pure C. The only C++ I'm really using is like operator overloading and stuff. So there isn't really even a concept of virtual in this. It'll all just be structs, basically. Everything's public and it's just structs. If you can give me an example of something you would want to use a virtual class for in this case, I might be able to explain it better, but that's not something I use normally, so I don't know if I can give you a concrete example for that. So I'm trying to see why this didn't generate a... I need a toString for myStruct. Color me confused why that's not... how did that compile properly? That's very confusing. ToString my struct value. My struct value? There it is. Oh, because it passes by reference. Okay, hold on. It did generate one. It's right here. So why don't... It's in primary chunk? Oh, there it is. Why is that in the primary chunk? Well, I don't know, but there it is. I found it. It took me a second, but we got there. That's confusing though, because the print function calls format string. The format string calls ToString. Oh, that's why. Okay. Because ToString is not being generated from a function template. There's an actual just straight up metaprogram that is run independently that's generating that, and that generates that on the first pass. That's why. These chunks only matter for things that are being generated by templates. I'm calling these templates. So like these functions that take any parameters, those are templates, and those are what generate the chunks. Anything that the normal metaprogram generates happens at the other level. That was confusing, but anyway, so that's one example of what I'm using the metaprogram for. Another very simple example is because it can read and spit out my code. Normally, if you saw here, I'm using this stuff before I declare it. And the reason for that is because the metaprogram knows what all my stuff is. It actually does a dependency map and figures out what depends on what. And when it spits out this final giant source file, it has been dependency mapped and puts this stuff in the right order. So the final C file that gets compiled is correctly in order, but the source code it came from doesn't have to be. So the code that I write is totally order independent, even though it's basically C code. On the other end, which is this giant C file, it figures out the dependencies and puts stuff in the right order. And even though this is kind of a giant gnarly mess, using these line directives, I can correctly point every line of code to the file and line number it belongs to, which both gives you proper error messages, and you can debug it. You can step through it like normal. So that's why I spit out these chunk files. I can step through these files without ever having to look at that giant mess. Yeah, so expanding on what they're saying is you can basically do a lot of static analysis of your code and spit out even more code automatically that doesn't have to do any second guessing. It can just live as static code in your program, even if that stuff is technically dynamic, because you just do a pre-pass on everything and spit out a bunch of helper code that then you can just use like normal code. It's like you have your own special little library being built every time you run the program. So like every time this metaprogram gets ran, it spits out a bunch of code for me that then is part of my main program when I compile it. And the stuff it spits out can be introspection information, it can be more functions like those print functions, it can be whatever it wants to be, basically. If you've never been exposed to metaprogramming before, it can be a bit of a head scratcher. There's kind of a lot going on, but I'm having fun doing this. So I started writing this C parser. It was starting out just as a parser for C. I started probably like mid-October of last year, and the majority of the time was spent setting up the parser. And only within the last couple months have I been really doing the metaprogramming stuff, and it's been going a lot faster, just because the parsing was the hard part, I think. So, and I wouldn't even really say it was hard, it was just very time consuming. and there's a lot of just validation that you have to go through. So it's just a little annoying, but okay, what were we doing here? Yeah, I need to resolve so this is not getting resolved. This is in short string. So no, this is in, what is this in? Print. So here's a case where value.value, this struct has a member called value. I'm calling it value here. So I'm trying to access its member value. And my resolving step is getting confused because it's like, okay, value, I know what this thing is. It is this thing up here that you passed in called value. Well, because this has the same name, it thinks this is also the thing I passed in, which is the whole struct. So with is it like reflection in C#? It gives you the ability to do reflection, but you don't really have to. So I do set up some stuff to let me do reflection, but I guess inherently it is reflection because you have to do that to generate useful metaprograms. But because as you can see, this tree here is my whole program in tree form. So it is reflection in essence, is like I can see my whole program as a tree and manipulate it, but so I could easily do that, but this is showing a fault in my parser that it is not able to. What should be happening here is this is a fault in my name resolution that I need to fix. Is that if you have God, where is it? How am I there? This is a fault in my name resolution. If this knows it's a member ref, when it goes to resolve this name, it should not be looking up the tree for it. It should be looking at, okay, if I'm the right-hand side of a member ref, go to my left-hand side and go to its definition. I'm going to be inside of its definition. I should be looking there, not up the tree. This left-hand side can look up the tree. That's fine, because it should expect to find it somewhere. This thing should not. This should be looking at its the definition of the struct it's a part of. And right now it's not doing that. That's where the problem is right now. And right now I'm just trying to figure out a way to do that cleanly. So, like, yeah, this isn't great, the fact that these are named the same thing, but it is valid code. That should work, right? So the fact that it doesn't is a problem with my name resolution stuff. So that needs fixed. By the way, I appreciate the follows. I've only started streaming like within the last month, and mainly as like motivation to keep busy. And it's been fun so far, so okay, let's see if I have, if this were if is right hand side. So let's just see if I can successfully find where we are a right hand side. Again, I don't need to be printing out the tree every time. Okay. So, is right-hand side. Okay, there are times where we find the right one. And this is arena. Oh, okay. Let's do one more check and make sure that if we're the right-hand side and express. So we have to make sure we're decal ref and value. If all of that is true, I want to step through this and see what it's doing. Okay, we should be on line 174, which we are, so we're in the right place. We don't have any children, so oh, wait a minute. I don't have to do this at the decal ref level. I don't have to do any of this. This is a red herring. I don't have to do any of that. None of this nonsense. If we're a function call, otherwise, let's just have a special case for member refs. Because then the right hand or the left hand side will have the authority, right? So if AST type is a member ref operator, right? So and let's say the line number is, what did we say, 174? Decal ref, the left hand side is value, and the right hand side should also be value, which it is. Okay. So in this case, I want to resolve the left hand side first. In this case, right? Which we already do, because we do our children first. So we do them in order. And a member ref, the left hand side is the first child and the right hand side. So, okay. Yeah, let's just have a special case. Member refs get a special case here. Once we resolve the left-hand side, we should be able to resolve the right-hand side from that instead of searching the whole AST. So if it's a member ref, otherwise so we will do our left-hand side, and then we'll do the right-hand side. But when we do the right-hand side, we will okay, I need to think about how to do this in a clean way. So what I really want to say here is connect Find and connect decal ref. I want to do a find and connect decal ref on the right hand side, but I want to do it starting from member ref left hand side. If member ref left hand side, so again we're just going to special case member refs. If we are a member ref, if we have a left hand side member ref, we're instead going to search do we have a name match? Search AST for name string. We're gonna look for, in the member ref left hand side, okay, that actually doesn't work. See, I don't want to do this the lazy way. I need to do this in a way that's robust. I can't just assume that the left-hand side is going to be or wait, do I already have this? Get to decal ref from member ref. If I pass in a decal ref, return the node. Otherwise, if I pass in a member ref, return the right hand side. No, that's not what that's for. Yeah, I need to think this through more. So if I was passed in the left-hand side, what can a left-hand side be? It can be a decal ref on its own. It could be a function call, which is really just a decal ref. It could be a function pointer, which is really just a decal ref. It could be I think it can only be a decal ref. You can't really, yeah, I think it's guaranteed to be something that resolves to a decal ref. If, let's just see what happens. AST expression function call. Then we will look at its first child. Short string decal name is node. So we will look for the decal name in there. Actually, and we will just have a case that will fail, that will catch other scenarios. Decal ref. This will be find and connect decal ref. That's what I was confused about. That needs to pass through this again in case we have to keep following the references. But if this left-hand side is a decal ref, then just go straight to the node that it's pointing to. Otherwise, report error and exit. Unhandled left-hand side case. Unhandled member ref left-hand side case. And we are at node. So I just go off of, so the question is, what if there's a global variable called value? If we were in C, right? So, because this started out as a C parser, right? If I had a global variable called node here, right? That conflicts with this node. So how does it know what to do here? Except for very specific cases, whenever I'm resolving these, it always starts from the call site, and I can actually show you that. It always starts from whatever you called in. So it starts from the decal ref's parent. So in this case, if I was trying to resolve this, it would start from its parent, which is this member ref. So it would look at this first. And if it didn't find it, it would go up to the next parent, which in this case would be this binary operator, the equals. So it would look at this whole thing. If it still didn't find it, it would go up again to this whole if. It still wouldn't find it. It would go up again to this compound statement. It still wouldn't find it. It would go up again to this whole function. And at that point it says, oh, now I did find it. There's a name that matches, so I can match to it. So it'll never even get to here, which is also how it would work in C. If I had node defined here and node defined here, there's no way in here for me to reference this outside one. You just can't. It has been shadowed by this one, right? So that's how my name resolution works too. It goes inside out. Except for very specific cases like this member ref case. If I know I'm the right-hand side of a member ref, I need to follow the left-hand side and just go to where it's pointing to. Yeah. So let's see here. Let's just see what happens here. Platform. Uh-oh. Okay, we're not even failing. We're not even failing everything we just wrote. We have now broken the... We have broken member refs in the code gen. Man, I actually don't like this. I don't like how special cased this is. I feel like this code wants to be as simple as possible. And what should really happen here, yeah, hold on, let's rethink this. Because I don't like mucking up this function like this. It feels gross to me. So, yeah, let's not do this first. So, are we back to where we were? Yes, okay. So, let's just step through. Instead of doing this, let's step through this and, okay, I need to... Okay. I'm just gonna step through the debugger and see at which point I want to insert this instead of kind of blindly throwing it in there. That just didn't feel right. I was mucking up too much code that I don't think I have to. So, we're on line 174. For each child, let's do our children first. So this will be the left-hand side, which should be value. So we should have connected that. And actually we didn't. We didn't even connect that. So that, I think, is our first problem. So this child is... Oh no, we did find it. I was premature. We did find it. We connected it to print helper number base value. Okay, we connected that. So we're good there. Now the child is the other value. So at this point, find the decal ref match upwards. Here, while parent. Okay, how about we do this? We'll say, before we do anything there, this seems like where this needs to be, upwards. Before we do anything, let's check if our decal ref... Damn it, I got rid of is right-hand side. I kind of want that. If is right-hand side decal ref, let's just make sure we get there. Okay. Parent is a member ref. We are 174. Yes. Okay, we're good. I'm just going to double check. Okay. So, if we get here and we're the right-hand side, we can still do this part and look upwards just so we don't break anything, even though we shouldn't have to. But if at this point we're the right-hand side, search AST for decal ref type match. So that's looking for, if we're the right-hand side, then we'll say left-hand side equals decal ref parent children 0. Let's just print that AST. Why don't we just print that? Oops, I don't want to do that for all of this. I just want to print it for this one case. No, I want to print my parent. I want to print the whole member ref. Okay, so in this case, here's what the member ref looks like. Left-hand side is value, right-hand side is value. So this is what we should be seeing at this point. We resolved our left-hand side. We know what it points to. We don't know what the right-hand side points to yet. What we want to do when we're resolving this is start here. Start at that point. Start at that location of the tree. So let's say search AST for decal node equals for decal name string, parser, left hand side, okay, so let's do that. And let's just see where that gets us. And let's just search through and see where we get. Step through this one at a time. Okay, that should print that out. And now let's search. Right, search AST. Right, this isn't following decal nodes. Okay, I just don't have... I thought I had functionality for this already. I just don't. So I'll just have to write that now. So in this case, I just don't have a function I can easily call for this. We're going to say... follow... left-hand side to decal ref. Or to decal. Okay, let's just write this. We're going to say it's going to take the... Do I need the parser for this? I don't think so. Left-hand side. So, we're going to switch left-hand side's type. And we're going to say... if it's a decal ref, we will do something. If it is a function call, we'll do something else. In any other case, if it's a function call, we need to do function calls have a return type node? Is that a thing? They do. Okay. They do. That's very helpful. Okay, so this result can just be left-hand side info dot. So we can grab this. This will be decal node. If decal node and well, yeah, just if it has a decal node, then we can just say the result is decal node. It's a decal function dot return type node. I mean, that's easy enough. If it's a decal ref, then let's just go to the decal. Let's do this again. But this time it's just on the left-hand side. If decal node type equals ast decal struct return decal node. Otherwise, actually don't return it. That's not what we're doing here. Result equals follow left-hand side. Let's just keep following it just in case we have to keep going up, right? It might be something that calls something that calls something. If decal node default parser follow. This doesn't need the parser. It also doesn't need that. Oh, if decal node, right, if decal node, then return we'll say return search AST for name string parser decal node and we froze. Okay, that's fine. Let's see what happened. Follow left hand side. Oh, that might be null, right? So if not left hand side, because we might just hit the end of a chain, which means we just didn't find one. We still crash though. Oh, we're recursing forever. Oh, wait, duh. No. If it's not a decal ref and it's not a function call, yeah, we don't do anything. There's nothing to follow. Oh, okay. If that's what I was trying to do here and I just wasn't thinking. If this thing is another member ref, then result, we could do this again. Follow left-hand side of left-hand side's first child. That's what I was trying to do. Well, we compile. That doesn't mean that we successfully hooked up our nodes, but still didn't. Okay. This should be here. We're looking for value. Okay. Follow left-hand side. The left-hand side is a decal ref, and this should also be value, right? It is. If it's a decal ref, grab the decal node, and its decal node is this. Oh. Okay, great. That's actually fine. Yeah, so this will be a switch on decal nodes type. If it's a struct, then we found it. Otherwise, it could be a parameter or a variable, in which case we want type node. It could be other things, I think. Well, no, because it's either a variable or a function call, or we found the struct. Ooh. Oopsie. Forgot about this. Did we fix it? We might have fixed it. E. Wait. Remember, value is EE. Which is this one. This is what? It's the struct member. We did it. We found it. It's hooked up correctly. That was a rabbit hole and a half, but holy crap, it works. So now, if we grep for unknown, what are we down to? $17. Wait, how did we go up? How did we go up? Oh, because we added some new ones. Okay. Oh, that actually makes sense because that's another case we're just not handling yet. If you're a member ref, if the left-hand side is another member ref, you go down and you grab the left-hand side. Okay, so this is a case we have to handle where follow left-hand side. If it's a decal ref, which it's not, it's a member ref, follow that. So if right hand side, so that's me right here, I am the right hand side because my parent is a member ref and I'm the second child. So let's call follow on this, right? And then, so we call follow on that. It's also a member ref. So let's call follow on, oh, no. If it's a member ref, I want this thing. I want, that's where that comes in. Decal, get to decal ref from member ref is what I wanted. If it's a member ref, I want get to decal ref from member ref of my left-hand side's children. Wait. That's not right, because that's going to be... No. So, I'm here. I'm the right-hand side, so I'm going to call it on this. Well, this is a member ref, so I want that, which is Follow left-hand side to decal. Oh man, why is this so confusing? It is though. So in this case, follow the left-hand side to the decal. Well, if my left-hand side is another member ref, then maybe this is what I want to do. Maybe I don't know. I'm a little scared about this. No. If I see a member ref, I need to call this on bro. I've been at this for too long. I've been at this for like 4.5 hours now, so maybe my brain is just getting tired of it. If my okay, I'm the right hand side. I need to resolve from my left hand side, which is what this is doing. If I'm a right hand side, I need to resolve from my left hand side. What is my left hand side? If it's a member ref, I need to resolve myself from this thing. Which means if it's a member ref, I need to resolve to it. Yes, get to the decal ref from... If this thing is a member ref, oh man, I think this is it. I'll just call this follow to decal so I don't... So I stop getting confused. Okay. Let's go through this again. Okay, follow to the decal of my left-hand side. So, this is my left-hand side, which should just be... Oh, this is the wrong thing. I've already fixed this one. What was I testing? Let's say string. Let's say I'm string. Okay, so okay, let's not do string. Let's do let's actually, yeah, let's do string, but let's also say, let's say that the left-hand side's type is also a member ref. That's what I need to do. Ah, stop. Okay. Okay, now, left-hand side. What? How is that possible? Right-hand side, decal ref, so I am head. What? Okay, this just didn't work at all. How did that just not even work at all? Okay, so this is the left-hand side. Oh, this is getting confusing. So here's the member ref. We want to do our children first. So this child should be string. Yes. And now we resolve us. Yes, we should be the right-hand side. Our left-hand side should be a member ref. Okay, I just had a hard time finding this. So let's follow it. It's a member ref, which makes sense. We are on line 66. Okay. String. So this is this builder string. Builder. Head. So I just want to know exactly where we are. Oh no, yeah, builder head. Yes, we're right here. Okay. So we're just trying to follow this until we get to a decal. So if this is a member ref, we want this. I want to recursively follow this down. So if I do get to decal from member ref node children 0, this is node children 0, get to decal ref from member ref. Oh, I am getting tired, I think. I've been at this a while. This should not, I should not be the children here. Node is a member ref, so I want to get to its decal ref and then follow that. Ooh. Hey, look, we're down to 12. Man, I may have to call. I don't want to stop in the middle of this, but I've been at this a while today, so. When you mess up like that, there are problems. So now if I look, actually let's do it this way. Let's just grep for unknown and see where we're at. Coming from the metaprogram, meta. These are not from the metaprogram. So we're down to 5 that are broken that shouldn't be. These I'll have to come back to. Okay, let's just see those. Why are those failing? Let's just get rid of this. Actually, let's not. Let's say, does this connect decal refs? Yes. If its type is a decal ref and its name is write error. Oh, wait a minute. If I get context on this, is this actually platform dot write error? It is. That tells me a little bit more about what's wrong. Okay, platform dot write error. Okay, that will actually help me. This actually might not be as hard. I might just be missing a case where I don't follow something the right way. So, write error, and its parent is a member ref whose left-hand side should be platform. Oh, left-hand side. Platform. Okay. Let's follow this. So, it has no children, so we're back here. This child should be write error, which it is. Okay. Let's find it. I am the right-hand side. My left-hand side is not a member ref, it's just a decal ref. So let's follow it to the decal. It is a decal ref. So decal node is a variable who has a type node. Okay, we found it. we found it. So search for name. Node match for string. We're looking for the string right error. And we're looking for... We're looking at each child of the struct. And the struct should have a child in here called... Are we not looking for functions? Are we just looking for variables? It should have a function in here called right error. Right notice. Right warning. Right error. Okay. So when we look in here, yeah, we don't grab functions here. Node match for string. Node match for string. In the case of a AST decal struct function. Do we have to match anything else here? Struct function. I don't think so. I think we're okay. Nice. I've been streaming for almost 5 hours now, and I think I'm losing my mind. But I didn't want to stop in the middle of getting this thing done. I do feel similarly, though. I will, like, code for my day job all day, and all I want to do is get home and work on my stuff. So, I know the feeling. Hopefully your 8 hours were successful and not frustrating. So if it's a function, I just want to see if we match by the name. Wow, we have some issues. If the function name matches, just give us that back. We should be less than 12 now. We're down to 8. That's a good sign. Metaprogram. Metaprogram, 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 metaprogram. This is not the metaprogram. So we're down to one unresolved node that is not from the metaprogram. We expect the ones from the metaprogram right now, but so let's take a look and see the context for that one. So it's a function call to allocate memory arena. That's, yep. I don't know, man. If you're working, like, don't sell yourself too short. If you're, like, working in C++ at all, honestly, like, I feel like you're already, I feel like, doing more than a lot of people you would think. And yeah, man, you're working on UI code in C++. Like, I mean, I don't know exactly what you're doing, but okay, let's see what this is. If it's a decal ref called, let's look for the function call whose first child's name. Sorry I didn't offer even coherent words of wisdom there. I'm obviously very tired and ready to call it a night on this. I am so close though. So close. Okay, so that didn't go anywhere. It's a function call whose first child is called allocate memory arena. Oh, that's up here. We're in a different spot now. We're here. This is a special case for function calls. We will go here. Okay. My parent is a compound statement. Are there more than one of me though? There's not. That helps a lot. This means I only have to look at this one. First child is a function name, so we skip it. Do our parameters. So our first one is arena temp. Do we resolve? We do. Our second parameter is a binary operator where we cast another binary operator, which is casting an integer. What the hell? Where are we? Here. We must be here. So, oh wait, I knew that, didn't I? I think I knew that. Yes. Yes. We're calling allocate memArena with arena temp, a binary expression, so that's where we are. So this should resolve to, let's see, allocate memArena. Allocate, nope. Platform, allocate memArena. Allocate memArena. Should take a pointer to a memArena, which is arena temp should resolve to that. A U64 size and a U8. Arena ring buffer should be a U8. Probably. Maybe. And what is megabytes? It's a snippet that returns a... Oh, that's where the casting comes from. This should resolve to a U64. We should be good there. We should be good. So let's see why we're not. So, we resolved the first one. There's nothing to even resolve here. There are no decal refs to resolve here. That's fine, because that expanded into a snippet, and we should be fine there. There's nothing to resolve. Right? So the third child is this decal ref, which is arena ring buffer. Do we do that? We do, and it's a bit feel... Okay, we found all those things. And now we do the function. So, why don't we find this? Wait a minute. Okay. So first, do we even find the name at all? We do. We found allocate memArena. We found it. Do we match the number of parameters? No. Oh, optional. Yes, because we have an optional parameter. So we do match. Okay, let's compare parameters. The first one should be does arena temp match what we expect it to be? We expect a memory arena pointer. And we get a memory arena pointer. So those should match no problem. Okay. Next parameter is it comes out to a U64. So we successfully resolved through all of this snippet nonsense to a U64. We get a binary operator, which resolves to a cast. Which resolves to... Yep. So that cast was a U64, so we're good. Fine. So we must be failing this last one somehow. We should be matching to a U8. And we're matching to... Nothing. It's empty. Why is it empty? I should not have gone so fast. Arena ring buffer. Its type is empty. Bro. This thing's type is... Oh, hold on. Is this another case where get param type... Do I have enum here? No, bitfield member. Get type string from declvar. Bitfield member. All right, let's step through this again. As much as it pains me to have to do this again. We matched on a function. Okay. We match on the count. Okay, let's go down to here. First parameter matches, second parameter matches, third parameter. Okay. Wait. Shit. I went too far. God damn it. Okay. First parameter matches. Second parameter matches. Okay. We're matching to a U8. And our declref is pointed to a bitfield member, which is arena ring buffer. It has no type. Okay. It has no type. Do enums have types? That's my next question I ask. Comparable type string. Hold on. Type equals. That's not gonna help me. Is it connect types? Enum member? I don't give it a type. I just don't give it one. Cool. We're gonna say to do. Can we have this grow nicely based on number of members? Seven? Is that less than we had before? I don't remember. Yes, we're good. Okay, all that's left are, and I guess if anyone's still here, to explain the problem that's left, which I'll probably leave for tomorrow or next time I stream. So the goal today was to get all of the unknown, all the decal refs that don't resolve to something, to resolve to something. The first step of that was anything that's coming from external code that I'm not parsing. So like these system headers. I don't want to parse stuff coming in that's not code that I wrote. I'm not interested in doing it, and it's a pain. So, especially because this is ballooned out from just a C parser. So I've introduced that. That introduces problems though, because then if I call, say, this write function, right, from the Unix like standard headers, this doesn't resolve to anything. I don't have a node on my parse tree for that, which means a decal ref can't figure out what type this is, what it doesn't know anything about this, so it screws up the metaprogramming. Before I just dealt with that, but I've started doing more things that really require that everything knows what everything is. And because I still don't want to parse system headers and go down that whole rabbit hole, or other libraries coming in. In fact, I can... Yeah, so anything that you're using that's coming from an external source, you have this new external keyword that says, hey, this is a variable called standard in file number, and it's a U64. This is a function called write. It returns a U64 and takes these parameters. So now I know if I'm calling this, I have something to match to. And this external keyword tells me not to emit any code. It doesn't generate any code for that call. So it's not going to be spitting out more code. I'm including the code for it. It doesn't have to spit it out, but it at least tells my program about it. So that knocked out a lot of these unknowns, because now I have a place for stuff I'm including. But then there were just a bunch of places in my code where I was just being lazy and not hooking stuff up properly. I've knocked all of those out now, and now all that's left are things the metaprogram is generating. Let's see, where did I have that? Turn this back on. So, down here, do I really not, did I get rid of that? What happened to it? What? This is no longer relevant. This is no longer relevant. I thought I had a to-do in here for... Really? Do I just not? Huh. Anyway, the problem here is that when I run this post pass and I want to verify that all of my decal refs have been tied to a node somewhere on the tree, there's no dangling like unknown references. In a case like this, well, where's the case where I'm doing that, right? Format string, right? So basically, if I'm calling a function that needs generated, so if I call like my generated function here, right? When it does this post pass, it doesn't know what this is, and it hasn't run the metaprogram yet. So this post pass, it runs, and then the metaprogram runs. So when it first runs this pass, it doesn't know what this is, but it also doesn't know that this is going to be generated by the metaprogram. So from its perspective, this is just a failure. It can't hook it to anything. It failed to hook it to anything, so it couldn't resolve. Even though in a subsequent run of the metaprogram, it probably will resolve. I don't currently have any mechanism to solve for that, and that's a problem, because I would like this to be an error that says, hey, we failed to resolve something. So if I turn this on and I try to build, I want it to be like, hey, we don't know what this thing is, right? This absolute value, we don't know what it is. It's short string 141. We don't know what this is. Well, why don't we know what this is? Because this is going to be generated by a subsequent run of the metaprogram. I think really the only thing I can do no, I can't use the templates to go off of this, because you might be generating functions out of the metaprogram itself. So yeah, I don't know what to do about that. That's going to be a problem for the future. I can leave it for now. It won't cause that big of a problem right now, I don't think. And I'll actually refer myself to this part of the VOD. And we are at like 5 hours. I can refer myself back to that explanation I just gave for future me. So yeah, I'll have to come back to that. But given my to-do today, I got that working. Right? This is all good. This is all good. So I'm on to some really fun stuff next. Besides that, I may just leave that for now and come back to it. But man, I was at this a long time today. That's good though. So yeah, I am going to call that a success. Let's push this stuff up. Okay. yeah, I think that's going to do it for me. Appreciate everybody watching. If you're still watching and you're someone who followed me, awesome, thank you. I'm going to keep at it. I'll probably be streaming more. I might stream tomorrow. It's probably will be limited to weekends. I tend to be running low on energy on weekdays these days, but yeah, thanks for watching.